All right, it's Wednesday. You know what that means? Book talk. Oh wait, there's no book talk. We're going to start our next book next quarter. You're going to get to pick the book that you want to read. I'll give you some choices, but we'll do that next week. Tomorrow is the test, so hopefully you've used the study guide and you've done that kind of thing. And today we're just wrapping up this whole idea of Darwin and descent with modification.
All right.
Hey now.
Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
Of course, as we study Charles Darwin, we know one piece of evidence he didn't have, which is super strong, is DNA evidence, and it tells us so many things, right? One of the things that DNA tells us, right, is that every living thing on this planet uses DNA or RNA to code for its proteins, basically to run its blueprint of life, right? That shows a common bond, right? There's only one language for all of life. If you think about it, that doesn't have to have been that way, but on Earth, that's the way it's happened. And so we are all descended from those first prokaryotic organisms that figured out how to, be captured in a bubble and then be able to copy themselves and pass on information to another bubble full of chemicals. And now 3.8 billion years ago, for a billion years later anyway, here we are, we're still doing the same thing with the same chemicals, right? DNA. Yeah, right. So we know that DNA codes for proteins, some DNA codes for switches, some DNA codes for Hox genes, but proteins are what we pay attention to. And mutations are changes in the DNA code that happen and are passed on over time. So you could tell how closely related two individuals are by looking at how closely their DNA is met. The fewer mutations, the more closely related, right? So humans, right, and mice have a more recent common ancestor because there are fewer mutations different between their hemoglobin DNA and let's say that of a frog, right? So humans, mice, and frogs all have a common ancestor, but the human and mouse one was more recent. That's what we use DNA evidence for. Here's a typical question on the regions. On the regions, they'll do something like, you have an unknown species, here's its DNA sequence, ACT, GCA, CCC, and which one is most closely related, right? Or which species are most closely related? And so you're looking for who has the fewest mutations, right? I mean, here this one, species one, has 2 differences, okay? Species 2 has 1, 2, 3, 4 differences. Species 3 has 1, 2, 3, 4 differences, and species 4 has just 1 difference. This G is a C. So you would say that species 4 is most closely related to the unknown species. That's a typical regions type question. Right, try this one. This one would be which 2 species are more closely related based on their DNA sequences. It would be which have the fewest mutations in common, right? Which is the closest. Good, if you said species 1 and 4 were most closely related, right? Because they only have 1 DNA mistake in between them, okay? Species 2 and 3 have, 2 DNA mistakes between them, so they're not as closely related to each other. And species 1 and species 2 have a number of mistakes, right? 1, 2, 3 mistakes. So 1 and 4 are the most closely related. Something else you might see on the Regents exam, one of these cladograms, right? This just shows evolutionary relationships. It says it was a tree, right? So you've got 4 species which have lines going to them. Where the lines meet shows a common ancestor between those 2 species, right? So it's almost like the farther down you go, the farther in the past you are. So number 1 was the common ancestor from A B, C, and D, right? For all four of them. Okay? A split off from the rest of the group. Number 2 was a common ancestor for B, C, and D, but not for A. Hopefully that makes sense. You'll see that on the regions. And of course, you might see a cladogram that looks like this, right? And they'll ask you, which 2 organisms between this group A, B, C, D, E, and F are share the most recent common ancestor. So you have to be able to read it. But this is kind of like time going backwards, and the most recent common ancestor was here between D and E. So they would have the most genes in common, right? The next most recent would have been A and B, right? And then if you look at this, you would say A and B have more in common with C than they do with D, because they have a more current recent ancestor, right? If all of these walked into the room together, A, B, C, D, and F, the 2 that would look the most alike would be D and E. The ones that would look the most different from each other would be A, F, D, and E. They would be A and F would be the most different from each other, right? F would be the most different. Hopefully that makes sense. Anyway, let's keep at it.